I hope you're okay that we're skipping ahead to 2.7. 2.6 is good material. It's just kind of tough to assign it when not everybody has a graphing calculator, and you sort of need a graphing calculator in order to do this or do that section. Whereas 2.7, you do not need a graphing calculator. We're looking at piecewise defined functions, and the reason why we call them piecewise is there's multiple pieces. And you can see in exercise 1 that we have two pieces, the top one and the bottom. Over here are what are called the constraints. And so the reason why we have what are called constraints is because we only do the top equation for x values that are smaller than 0 or they equal 0. And then we go to the bottom equation, bottom, if the x value we're talking about is bigger than 0. So these constraints, sometimes I call them conditionals. They are what you look at first to determine, are you going to the top equation or are you going to go to the bottom equation? So I'm trying to color code this so it makes perfect sense. That when I do f of 2, you look at these constraints first. Is 2 smaller than or equal to 0? No, it's not. So then you look at the next one. 2 is bigger than 0. So that's telling you to go to that equation where it's negative. Now plug in 2 in for x. And you figure out that f of 2 equals negative 3. So as I go to f of negative 6 now, go to your constraints first. Is negative 6 less than or equal to 0? Yes. So go to the top equation, and now you plug in negative 6 in for x. Well, you get negative 12 plus 3, you get negative 9. So as I scroll down and do f of 0 now, f of 0, go to your constraints first. Is x less than or equal to 0? Well, it is equal to 0, so yes. Go to the top equation and plug in 0 in for that x. So 0 times anything is 0 plus 3 is 3. So that's how you would evaluate piecewise functions. Well, what if you were asked to graph them? So we're still going to use the xy axis. Now, sometimes when I teach this, I tell my students to look at these constraints first and just draw the constraint, x equals 0. Don't worry about less than, don't worry about greater than. Well, this is a vertical line at the x-axis, or where x equals 0 is actually the y-axis. And so what happens is we have two different pieces. Let's see, I think I used purple for the top piece. These are to the left of 0. So there's somewhere over here is where we're going to graph values that are to the left of 0. And then this equation is greater than 0, so to the right of that constraint. So we only draw the linear function that's purple. Let me go back to purple, that's to the left. Now traditionally we would write this as, we would go up to 3, so count up to 3. We would put a dot right there, and then we would count up to right 1. Well, look, we're in the red part of that graph, so I don't want to go up and to the right. Well, what's the opposite of going up and to the right? Down and to the left. Whoops. Down and to the left. So we only graph that purple equation to the left of those values. Now you'll notice if I were to graph this at negative 6, it was the y value of negative 9. And you can see when x is 0, you do get 3. Now there's one more thing that you need to know. Because x cannot equal 0, you still want to find the y-intercept of this problem, which is down to negative 1. But you put an open circle because it cannot equal 0 at that point. And then it's down 1, right 1 from there. Down 1, right 1. And if I go back a slide, where it said when x was 2, y was -3. That point is definitely, I think it's right here, to -3 is definitely a value on there. And you already guessed it, Desmos will do this for you. Now, one problem though is the way you write it in is really tricky. You have to write in this brace, which I had to shift, hit the bracket key on my keyboard, and then I have to type it in the way it looks. 2x plus 3. I think what I'm supposed to do though is put my bounds in before it, less than or equal to 0. There we go. And I should zoom in quite a bit so you can see what I'm looking at. And then inside of this, I put a little comma and say, well, what about when x is greater than 0? Then that function was -x minus 2, I believe, if I go back to, nope, -x minus 1. You can tell I might be good at math, but I have a terrible memory. Now, as I click on my graph, you can see when I put at x equals 0, it jumps up to 3. So there is, maybe if I zoom in, you can actually see that it does not equal, like there's a hole in the graph, right? It's not letting me see. So Desmos has its downfalls as well, but this is exactly what we said this would look like. So I would practice, if I were you, playing with Desmos and seeing if you kind of get it. I don't know if you can hit enter on, no, you can't hit enter to separate it, so this is how you would type it in if you want to check your work. All right, let's feel free to pause the video and play with Desmos on your own, and I'm going to move forward explaining our transformations. So you probably remember doing all these from Algebra 2. I'm just going to highlight a few things for you. That when you add to a function on the outside, it shifts up however many c is. Like c could be 8, shifts up 8 units. I just made up that number, by the way. If you subtract on the outside, it's down that many. Let me just change my highlighter to a different color. If you add to the x value that is left, and you probably remember being frustrated with Algebra 2 when it went backwards, minus to your x value went right. A negative in front reflects over the x-axis. I don't think we'll have any of these ones where we reflect over the y-axis. The book is not very difficult. I meant to change colors. Let me change colors now. And then we might have a few of these other things. But the big things is up and down, left and right, and reflecting. The other big things, again, feel free to pause the video at any point, is this book only asks you to do a few things, like a quadratic we've seen before is a parabola, a cubic, a square root function, and then the absolute value. Okay, and I Googled, and this is what came up. I think that covers all of our bases. And then don't forget about our linear function, which we've actually done quite a bit with already in Chapter 2. And so what we're going to do now, I guess I'm getting ahead of myself, is we're going to practice shifting and reflecting. And just so you know, these rules still apply to other functions like cube root, exponential, logarithmic. These are all functions that you've either seen before or that we will be doing at some point this year. And you're probably familiar with these transformations as well. And again, these are all laid out for you. You can pause the video at any point, read this a little bit closer. I'm just going to highlight some of the things. Remember, when you subtract inside with the x, it is right that many units. When you add inside, you can see the square root. That's what I mean by inside. It is left. Negatives, flip it upside down. There's a few examples of these. A few more examples of adding on the outside, not with the x, but on the outside of it. It shifts up. Subtracting on the outside shifts it down. And then we also have a few other transformations, and we can combine all of them. So like this is a cube function, right 2, down 4, and reflected, because the parent graph goes up and to the right like this. Reflecting it makes it go down and to the right. And you can see it's shifted right 2, down 4, and then you can draw the graph. I know I went through that really, really fast, but you've done this in Algebra 2. I know you have. And last year I only did one example, and they were all good that I didn't do any more because they remembered it. So what's your parent graph? Okay, well, it's the absolute value. Okay, well, absolute value is that V shape. And by the way, Desmos will help you. If at any point you get stuck, you do have Desmos, the graphic calculator, to help you. This is reflecting. So it's a downwards V. This plus 2 means left 2. Minus on the outside means down 1. And you can use this as a reference because I don't think I'm going to have any other ones. You might also need to, I'm going to go back for a second. You might need to reference these parent functions. Going back to this, so your final answer for h of x is, I would do the vertex first. That's what we call this bottom, by the way. That's called the vertex. So I would shift left 2, down 1. Let me go ahead and label it the vertex. It's the ordered pair -2, -1. And then it's a downwards V from there. Downwards V from there. And this is h of x. And I could do these problems all day. They're not too difficult once you get practice with them. And like I said, we're not going to do many other things besides up and down. So plus on the outside is up, minus on the outside is down. Left and right, left is plus inside, right is minus inside, and then the reflections. And so I think you have enough information to be able to do all of these problems. Feel free to reach out if I don't have enough examples. I can do these all day.